Welcome back to another episode of Learning Integration. This episode I'll be focusing on integration by substitution, and the focus will be on the exponential function of a to the power of x. So obviously here we have a function a to the power of x, a being a number. The integral of that function being a to the power of x over ln of a plus c. So say 7 to the power of x would be 7 to the power of x over ln of 7 plus c. Okay, I'm going to start with an example. No better way to start. Example 1. Let's say we have a function called, let's use 7 as example. 7 to the power of x multiplied by sine 7 to the power of x. Okay. Now, when we're thinking of using substitution, first we've got to see if it's a function times a function. Yes, it is. Then we've got to see if inside one of them, which would be sine or whatever, is the derivative of this able to get rid of the derivative of this. Is the derivative of this able to get rid of this, is what I should have said. And yes, if you can't see it, that's fine. I'll show you. But first, we've got to write the integral of both sides. So capital F for the integral, and then for this side we use the integrand symbol, followed by a dx at the end. Okay, now's when the substitution part comes in. Substitution, or sub. We're going to sub in u. I'm choosing u because I want to. And I'm going to sub in 7 to the power of x. Just like I said, if we can derive this, and to help get rid of this, that's what we're going to do. So we're going to derive 7x as such. And the derivative of 7 to the power of x is ln 7 multiplied by 7 to the power of x. Don't get this confused with this. This is the integral. This is the derivative. So, yeah. Okay. We have a dx here. We have a dx here. This dx is multiplied onto this, therefore we can use it. If we isolate this dx, we can use something and replace it in here, which is what we're going to do. So, if we keep the du where it is, multiply the ln 7 multiplied by 7x down, and multiply the dx up, we get dx on its own. And if we rewrite this, we get 7x sine u du over ln of 7 multiplied by 7 to the power of x. Okay, now I've done something a bit different here. I labeled, firstly I switched them. I switch the dx in for the du over ln 7 to the power of x because they equal the same thing. So I subbed this in. And also, I said u is 7 to the power of x. That's why I subbed in u here, where the 7 to the power of x was. I didn't change here, and I didn't change it on here. That is only because I'm going to get rid of them. So 7 to the power of x divided by 7 to the power of x, get rid of them. Therefore, what we're left with is 1 over ln of 7 multiplied by du multiplied by sine of u. And because 1 over ln of 7 is a constant, because ln of 7 is not a function, or it's not an x or anything, it's just 1 over ln of 7, it's a number. So multiplication by constant means we can bring that number out the front. And I'll show you exactly what I mean when I say that. So we have our fx, capital Fx, and then we have our 1 over ln of 7 sine u du. Because this ln of 7 is technically 1 over ln of 7 multiplied by du. This is just a simplified version. So I'm just bringing this out and then out the front, because it's a constant, so you bring the constants out of the integration method process. So Now we have it on its own, ln of 7. Now we got to find the integral of sine of u with respect to du. Now, what's the integral of sine? Negative cosine of u plus c. Okay, so now we've got to multiply this 1 over ln of 7 back in. Expand the brackets. So we're left with negative cos u over ln of 7 plus c on ln of 7. Just remember, just because there's a c here doesn't mean we don't multiply this in. If we have a constant at the front and we do the integral, we have to multiply that constant back into each part. So, therefore, if I don't like seeing that, I like it just being a standard constant. This is the right way and this is correct, but I want to say h equals c over ln of 7. Therefore, next time I write this, I can write it as h. So, what's u? We said u was 7 to the power of x. Therefore, I can rewrite this as, I'm going to bring the h at the front because it'll be a positive. So, h minus cos 7 to the power of x over ln of 7. Okay? That's the first example, and that's the first example done, and that is the integral of 7 to the power of x multiplied by sine 7 to the power of x. Okay, now let's do another example. Okay. A function equals e to the power of x multiplied by 10 to the power of e to the power of x. Okay, so if I derive whatever's in the brackets up here, will I get something to help eliminate that? Answer is yes. So that's what I'm going to do. First we find so I'm going to use substitution to solve it, is what I should have said. But now we're going to find the integral of either side, capital F to signify integral, and we're going to use the integrand, e to the power of x, multiplied by 10 to the power of e to the power of x, dx. Okay, so I'm going to say sub u in for e to the power of x. Then I'm going to say the derivative of u, well, the derivative of e to the x is just e to the x. So if we do a bit of rearranging, divide the e to the x down and multiply the dx up, we get a dx on its own. And now we can sub this in for this. Okay, if I rewrite this, we have the integral of e to the x 10 to the power of u du over e to the power of x. Now, I did like before, I didn't make this u and I didn't make this u because I'm going to cancel them out. Because it's e to the x divided by e to the x. Okay? Now, some people would, if you had that as u and that as u, you could just still cancel them out because u divided by u. But I like seeing it as I'm getting rid of it, because I'm weird like that. Okay, so we have integral. Now we have this side, which now equals 10 to the power of u du. We established at the beginning and in the previous question that the derivative of a number to the power of an unknown, which is u, is going to be 10 to the power of u over ln of 10 plus c. Okay? Now, I want to sub u back in because I want to have this complete and done. So we rewrite it and we have 10 to the power of e to the power of x over ln of 10 plus c. And there it is. That is the integral of e to the power of x multiplied by 10 to the power of e to the power to the x. Okay? I hope you learnt something. Thanks for watching, and I hope you have a good day.